Hi, hello, welcome to Dr. Zahid Math. Today in this video, I'm going to teach you two ideas. One is population growth and Newton's law of cooling. So why this population growth is needed in the differential equation course. So population growth is usually used in real life to predict how fast a country's population increases. For why? To plan resources like food, water, and housing. In engineering, it helps in designing cities, transportation systems, and healthcare facilities. Right? As an engineer, you should plan all these things, depends on the population. And the next thing is Newton's law of cooling. Why this is needed? Newton's law of cooling is used in food industries to check how quickly hot food cools down, and in forensic science to estimate the time of death. Engineers use it in designing cooling systems for machines, engines, and somewhere in electronics also. So in both the concepts, for example, population growth and Newton's law of cooling, in both the ideas, it helps in solving real world problems by understanding how things grow, especially in the population. And in the Newton's law of cooling, it's how the things are cooling over the time. So in this way, we are going to study today about the model of differential equations in population growth and Newton's law of cooling. So let's get started. MA203 elements of differential equation, exercise 3.1, population growth and Newton's law of cooling. This is in module 1, which is the last topic of module 1. Okay, right. The first thing is we're going to study about linear models. So the one thing, population is also related to bacterial growth, right? So what is the differential equation for bacterial growth? The differential equation for the bacterial growth is dp divided by dt is equal to k times p. This is the differential equation. How? Let's talk about your differential calculus. dy by dx. What's the meaning of dy by dx? Y is differentiated partially with respect to x. Or you can say another word, rate of change of y. What is the meaning? Rate of change of y with respect to x. It means what? The y will be keep changing according to the change of x, right? That's the meaning. So rate of change of y with respect to x. Now let's talk about population. I call the population as p and the time as t. Population means what? The growth, right? The baby is born in the hospital, right? So the baby is born according to the time, right? So the population depends on the time, right? So as population increasing, the time is also increasing. So it means what? The rate of change of population with respect to time t, right, is proportional to p. P is what? The population. So if you want to make it equal, what happens? dp divided by dt is equal to what? Kp. What is K? K is called constant of proportionality. Whenever you use ratios, we use what? Constant of proportionality is K. So you get the differential equation dp divided by dt is equal to Kp. So this is the differential equation for population growth. It can be babies or it can be any bacteria also. Right. So what is K? K is called constant. Right. How many constants are there in this differential equation? There is only one constant. So every question of population growth, first you need to write this equation dp divided by dt is equal to Kp. After that, try to solve this differential equation and get the solution for all the questions. And then you start reading the given question. Right. Let us try to solve this question. Okay. Right. Solve this equation. dp divided by, this is p, I'm bringing here, is equal to k, and dt I'm bringing over there. How? Using variable separable method. What is variable separable method? I told you x with dx and y with dy. At the same time, dx and dy should be in the numerator. Dx and dy should be in the numerator. What do you mean by numerator? This is the top, right? Dx and dy should be in the numerator. This is called variable separable method, right? Yes. In this case, we don't have x, we don't have y, we don't have dx, and we don't have dy. We have p and dp, t and dt. So it means what? P with dp and t with dt, and dp and dt should be in the numerator. Okay, so this is called variable separable method. So I separated the variables. Now you can see dp divided by p is equal to k dt. P with dp and t with dt. Once again, where is t, teacher? T is nothing but t power 0, right? Now the variables are arranged. So p with dp and t with dt, at the same time dp and dt is in the numerator. I can start the integration. So once integration starts, right, let's start the integration. Okay, so dp by p is what? ln p, which is equal to k is a constant and integral of dt is what? T plus integrating constant c. So this equals ln p, right, is equal to kt plus c. This equation is designed for population growth. So our job is to find this p, right? Yes, p is locked inside ln. So I told you, if p is locked inside ln, you need to take this ln out using exponential functions, right, which is called as pick and tick rule. I told you in the class, pick and tick rule. What is that? It has e. Now you just pick and tick. So p equals e power kt plus c. This equals p equals e power kt and e power c. We can write e power 2x plus y as e power 2x and e power y. Okay. Now p equals, I told you, c is a constant, right? And e is also a constant, which is 2.3 something, which is a constant. So e power c, number to the power number. So both are going to be what? Constant. Instead of having two letters e and c, we can make it a single c. So e power kt. So p equals c e power kt is the solution of the population growth differential equation. This is the solution. This is the solution of the population growth differential equation. Population growth differential equation. Clear, everybody? Right. So what is your population equation? The population equation is given by dp by dt is equal to kp. This is the differential equation. Okay. What's the differential equation? dp divided by, sorry, let me write exactly same as that. dp by dt is equal to kp. This is the differential equation. And this is the solution of the differential equation. Okay. So for every question for the population model, first you need to find this step. Once you find this step, that is the solution. After that, you can start doing the solution for the current question, which is means what? The particular question given in the test or exams. Let us read this question. A population of a community is known to increase at a rate proportional to the number of people. Population is proportional to the number of people. So it means what? dp. At time t, so dp by dt is proportional to p. Population, number of people, time t. This is the equation. If the initial population is p naught, so what is given? Initial population is given, right? So what is given? The given is initial population. Initial population is equal to p naught. Initial population is p naught, which is given. Okay, initial population is p naught, has doubled in 5 years. Initial population p naught is doubled in what? 5 years. Okay, 5 years. So it is doubled in 5 years. Where is that? So doubled in 5 years. Okay, 5 years means the time. Okay, doubled in 5 years. How long will it be triple? And how long will it be quadruple? So it means how long means what? T is equal to question mark. So when the population will become triple, okay, T is question mark. When the population will become 4 times, quadruple means 4 times. Okay. So when means what? T. So what is the question? The question is, okay, right. So the question is when the population time, when the population will be what? Double, right? Double or triple? No. When the population will be triple. Sorry, I'm writing double. Double is already given. So when the population will be triple and when the population will be quadruple, which is 4 times. I can write 4 times. Okay, 4. So this is the question. Clear all of you? Right? So there is a word given initial population, but initially our constant is C. So I'm going to write this equation. P equals P naught is equals what? P naught e power kt. So it is given in the question initial. So P equals e power k naught. Let's go to the first one. How many constants are there? Only one constant. So to find the constant k, step number 1. Okay, right. So to find k, we are going to use this condition. Okay, right. So initially it is doubled. Initial population is doubled. So 2 times p naught. 2 times p naught, which is p is equal to 2 times p naught, initially doubled at t is equal to 5 years. Right. So let's take this equation. Every time you have to take this equation. P equals P naught e power kt. Right. Now I'm going to put P is equal to twice times P naught, which is equal to P naught e power kt. P naught cancels. Oh, sorry, T is also 5. T is equal to 5. Right. So 2 equals e power k5. Directly put in the calculator. Type this equation in the calculator. Type the equation in the calculator. Type. When I say type, you're going to type. Type the equation in the calculator, right? And then use shift calc equal. Shift calc and then equal. Okay. So you get L minus R is equal to answer, right? So let me check this also in the calculator, right? 2 alpha equals alpha e power. K is not there, so you have to use x. So which is 5 alpha x. Where is x? Yes, here. Then use shift calc equal. So when I use shift calc, I'm getting the answer k is equal to, it's getting more time, k is equal to, still it is getting more time. Yes, I got it. 0.1386294361. Keep in your mind, you have to write all the decimals. All the decimals you have to write. All the decimals. Usually I say, or I said in the class, 9 decimal values you have to write so that you will get the correct answers. Okay. Right. So I got the value of k is equal to this. Now what I will do, I'll go back to the equation. What is my equation? My equation is, initially my equation is P is equal to P naught e power kt, right? So P is equal to P naught, this one e power, my constant is 0.138629436 t. So this is my equation, I got it, right? So P is equal to this. I need to box this. So let me write it once again without space. I wrote it. So let me write it with a space. P equals P naught e power 0.138629436 t. So this is my equation, right? So this is the population equation or population growth equation, right? Now we have 2 questions. What are the 2 questions? How long will it be triple? How long will it be 4 times quadruple? So how many questions we have? We have 2 questions. How many questions we have? 2 questions. The first question is how long triple? How long the population will become triple? This is the first question. And the second question is how long, okay, the population will be quadruple, R-U-P-L-E, quadruple, okay, quadruples, Q-U-A-D-R-U-P-L-E, quadruple, okay, how long? It means they are asking T, okay. Right, let's go to the equation now. So what is given? How long? Quadrat. So it means the population, it will be triple, right? So P equals how much? 3 times P naught. And here quadruple, right? So population P equals what? 4 times P naught. So let's go to this equation, right? I'm taking this equation here, right? Slowly. So 3 times P naught is equal to P naught e power 0.138629436 T, right? Here it is P equals 4 times P naught, which is equal to P naught e power 0.138629436 T, right? So P naught gets cancels, P naught get cancels. So let's have this equation 3 equals e power 0.138629436 T. Put in the calculator the same idea which I told you. 3 alpha equals alpha e power 0.138629436 bracket open alpha x bracket close shift calc equal. So when I use this one, what is my answer? So it will be T equals, that is X equals 7.9248128250. T is the number of years. So you can approximate to 724923, whatever it is. 7.92 is enough. Or you can say 7.48. This is okay. This is a number of years. Let's go to the other side. We put this equation, don't close it. You just go back and type just in the last one. Don't close this because remaining all the values are same. Just close this 3 and make it 4. Shift calc equal. Okay, so when I use this one, my T is equal to, I'm getting exactly 10. Wow, nice. T is equal to 10. If you use all the 9 decimals, you'll get like this. In case suppose you make approximation in the beginning itself for these things, 1 or 2 decimal values, if you write, you won't get T is equal to 10. Different answer will come. Okay. So this is the question, how to calculate the T value. Is it clear, this question? Very clear? Right. So let me recollect again. For the population growth, you need to take this differential equation. This is the differential equation. You have to solve this differential equation. After solving this differential equation, you try to put the condition to get this constant K. Okay, right? And initial population, that C already given as P naught. Then we have 2 questions. How long will it be triple and how long it will be 4 times, like that. Let's do some more practice questions. Okay, right. Let me give you one more question in this, right? So the question is, also I've taken this question from the book. Okay, right. So it is similar to the population growth model, but it is not bacterial growth. It's a human population, right? Let's read this question together. A city had a population of 25,000 in 1960. So what is given? Let me write all the details here, right? In 1960, right, the city had a population 25,000. Let's take Yanbu for example. And a population of 30,000 in 1970. So every 10 years they are jumping. You just see here. And 30,000 population in 1970. Assume that the population will continue grow exponentially like this. Okay, like this, sorry. It grow exponentially, right, at a constant rate. What population can its city planner expect in the year 2000? So in the year 2000, they are asking what will be the number of people in Yanbu, for example, right? Or take any cities, New York or whatever it is, right? In 1960, the population is 25,000. 1970 the population is 30,000. In 2000 what will be your population, right? So let the details will be there. Let me start the question. What did I say? For any differential equations, you just take population growth model. dp by dt is proportional to what? P. So dp by dt is equal to what? Kp. Right? Using variable separable, dp divided by p equals k times dt. So now we are going to integrate this one. ln p is equal to k times t plus c. ln is locked, p is locked inside ln. So pick and tick rule, there is a e here. So p equals e power kt plus c, which is equal to e power kt e power c, which is equal to e power c is a constant. So e power kt times c. So this equals population c e power kt is your population solution or solution of the population growth model. We can say like that. So how many constants we have now? 2 constants. How many constants we had in the previous question? Only 1 constant. Why? In the question itself they gave initial population is P naught. It was given. So immediately we put this C is equal to P naught. But here they didn't say anything initially. Look at the question. They didn't say anything initially. Just see here. 25,000 in 1960, 30,000 in 1970, and what will be the population in year 2000, right? So nothing is given regarding initial. So when the data, this is the data, right? The data is coming to the statistics department. So they give this data from the hospital, they give this data to the statistics department. So the statistics department receive the data. When they receive the data, which is time t equal to 0. Time t equal to 0. So when time t equal to 0, your population will be what? 25,000. So if you see here, every 10 years from the hospital, the data is given to the statistics department. So this is the model. So they didn't give 1965, they didn't give 1962 like that. So every 10 years they are jumping. So 1970, t is equal to 1. It will be 30,000 the population. Okay. So at t is equal to 2, it will be 1980, and t is equal to 3, which is 1990, and t is equal to 4, 2000. But these two datas they didn't give and they didn't ask you also. They just directly asking what will be your population in the year 2000. Year, this is the year 1960, 1970. 2000 all year. Okay, right. So what is the data given? The data given is t is equal to 0. What is the data given? Let me write simple English. So what is given? What is given, right? At t is equal to 0, p is equal to 25,000. And t is equal to 1, p is equal to 30,000. And what is the question? The question is, at t is equal to 4, right? And what will be your population at the year 2000? Clear? Right. So let's start this question. So p equals c e power kt. So to just find first constant, to find c. Right? Yes. So what is that? First condition we are putting t is equal to 0, p is equal to 25,000. So let me put here, okay, right. P is equal to 25,000 is equal to c e power k into 0. So 25,000 is equal to c e power 0 is 1. So which is c is equal to 25,000. Clear everybody? Right? You can also put this in the calculator, but not necessary because its e power 0 is 1. So finally my equation takes the model, this one, right? This takes the model. P equals, put the value of C, 25,000 e power kt. This is my equation. Okay, right. Now we are going to put the next condition. Okay, we are going to put the next condition. So now my equation is P equals 25,000 e power kt. This is my equation. Once you get every constant value, try to put in the equation and get it ready. Okay, make it ready. Now we are going to find k. So to find k, in the previous question we did not find c because why? They gave initial population as p naught, remember? Right. So to find k, what is the condition given? T is equal to 1, the second condition. Okay, t is equal to 1, the second condition. So p is equal to 30,000. Okay, 30,000. So you go back to this equation. P is 30,000 equals 25,000 e power kt is 1. Okay, so you need to put this in the calculator to get this answer. The number is so big, so make sure. So let us simplify. Instead of directly putting in the calculator, takes more time. So let me do one thing. I will divide by 25,000 here, divide by 25,000 here, because the number is too big, the calculator will take more time. Okay, so 0 0 0 0 0 0, so which is 30 divided by 25 is equal to e power k. Now you put this one there, easily you will get the answer. Okay, so let me press 30 divided by 25 alpha equals alpha e power alpha x, close the bracket, sorry, shift calc equal. So if I do this one, I get k is equal to, see this itself taking more time, k is equal to yes, I got it, 0.18232155668. All the decimals please write it, otherwise you won't be your answers won't be correct in the last step. Right, so what happened to my equation now? I have to put this value k. So p equals 25,000. Okay, e power k I have to put. K is 0.18232, right? 15568t. Okay, so this is my equation, the final equation. All the constants are gone. So final equation means all the constants should be gone, right? Now let's come to the question. These are all the things we just find out the constants. What is the question? The question is, in the year 2000, in the year 2000, what will be the population? This is old history, right? Okay, now we are in 2025. What will be the population? So we already told t is equal to 4. How? I just jump, remember? T is equal to 0, 1, 2, 3, 4. So I'm jumping t is equal to. I'm not taking the number of years, I'm just taking the time model. So t is equal to 4, what will be your p, right? So we are going to put this one, right, in this. So here we are going to put it. So population is a question mark, 25,000, okay, e power 0.18232155668 and t is equal to 4. Let us start putting this in the calculator. So what you need to do, you need to put x. Okay, yeah, alpha x alpha equal 25,000, okay, alpha e power and then 0.18232155668 multiply by 4. So I'm opening the bracket, closing the bracket, shift calc equal. So when I press this one, I'm getting population p is equal to exact number 51840. So this is the population in the year 2000. It was in the year 2000. Okay, it has already gone 2000. I think you have got cleared this model, right? So okay, one thing I want to tell you now, from today onwards, from this video onwards, I'm going to save this as a PDF, okay, according to your request. Save as a PDF in my Google Drive and I'll share the link in the first comment and the description box. Okay, right. So you can open this document and you can see this document while you are studying. Okay, right. Some pages I put extras because sometimes solution goes more and I cannot add pages when the video is on record. So pages will be extra, so nothing to worry, no problem, right? Let's go to the next model, Newton's law of cooling, right? So there was a mistake in the class itself. I told you this question. You need to do something. How long will it take for a cake to cool off? Cool off to a room. How long will it take to cake cool off? Okay, at the room temperature. No, cool off 70.5 degree when the room temperature is a room temperature is 70. Okay, right. Yes, let us read this question. Before reading, I'll explain this Newton's law of cooling. Also chemical engineering students, and also in physics you studied in many places. The equation is, don't take this one, just forget this one. Okay, right. So dt divided by small dt is equal to minus k times t minus a. So capital T is the temperature, okay, and small t is the time, okay, and a is the room temperature, okay. Why, teacher, the room temperature is coming here? We explained in the class. Room temperature is coming. Why? Because it's a Newton's law of cooling. When the coffee is prepared in the kitchen, when you're bringing this coffee to the living room, the temperature is getting reduced, right? So that's for we need a room temperature. Whereas the population growth, we don't want any room temperature, right? Bacteria can grow in any situation. It can be hot, it can be cold, like that. Babies can born in any temperatures, right? So the room temperature is not necessary for the population growth. Whereas the Newton's law of cooling, the room temperature is must because it relates with the heat and cooling. So automatically when some products getting cooled down according to the room temperature, if the room is more cold, immediately the coffee gets down cool quickly. Whereas the room is so hot, it takes more time to cool off. So that is why the room temperature is very, very important in the Newton's law of cooling. Then what about this minus, teacher? What is the use of that? The temperature is keep decreasing. So that is why this minus is there. Okay, keep in your mind. So whatever may be the question for Newton's law, if the question is Newton's law, you have to take this equation dt by dt, which is equal to minus k times t minus a. This is the differential equation for Newton's law of cooling. What is this called? This is the differential equation for Newton's law of cooling. Newton's law of cooling. This equation you have to remember. Equations will not be given. You have to remember this equation. Okay, this is the Newton's law of cooling. Once again, I'll repeat. What is your T? This is your temperature. And what is this T? This T is the time. Okay, temperature in the sense what? We can say temperature. Yes, temperature of the room. No, it can be anything, right? Yes. So A only room temperature. Keep in your mind. Okay, right. So you can say K exactly. Technically, if you want to say it is cooling constant, you can say like that. Because it depends, cooling constant, and this A will be the room temperature. Okay, right. So temperature, time, cooling constants, and everything is ready. Now we are going to solve this differential equation. Okay, look here, right? So this one is related to T using variable separable method. dt divided by T minus A is equal to minus K times dt. Right? Understand? Let me explain variable separable method. X with the dx, y with the dy, and dx and dy should be in the numerator. Then only we can start the integration. What about here? Here t and dt. T with the dt and t with dt. This temperature with the differential coefficient temperature. Time with the differential coefficient time, and this dt and this dt should be in the numerator. One is related to temperature, one is related to time. Let's check. Wow, t with the t, and this t is here. Where is the teacher? T, it is t power 0, right? So dt is in the numerator, dt is in the numerator. Okay, let's go for integration. Right, so the derivative of t is dt and the derivative of the room temperature is 0. So I can take ln t minus a. How, teacher? Simple example. Dx divided by x minus 2. What is the differential of x? Dx. What is the differential of 2? 0. So we take ln x minus 2, right? Same idea. This equals minus k is a constant. Integral of dt is t plus integrating constant c. Okay, right. Now what is our work? This is a differential equation, right? dt. So this is like something like dy by dx. So I need to find this. This is the question mark. So you need to bring the equation t is equal to. Okay, right. So t is equal to, you need to bring the answers, right? So t is inside ln. So it is locked by e. So we are going to use the rule pick and tick, right? Yes. So let's start now. So t minus a is equal to e power minus kt plus c. Okay. So t minus a equals e power minus kt. Same idea. E power c. C is a constant. E power c is a constant. So you can use c or c dash or a or b, whatever you like. No, a should not be used because room temperature is a. So t minus a equals e power minus kt times c. So this can be written as t minus a equals, let me bring c in the front so that it will be beautiful, c e power minus kt. What is my answer? I said any differential equation dy by dx, it means your solution will be y equals. Now your differential equation is dt by dt, so your solution will be t equals. Clear? Right. So now t equals, this a goes that side, as minus becomes plus, a plus c e power minus kt. Okay, right. How many constants are there in this equation? For the population growth, 2 constants. For Newton's model, 3 constants. It means we need 3 conditions to solve this. Okay, 3 constants. Okay, right. So either 3 conditions or 2. Why, teacher? Because one is a room temperature. One is a room temperature. Sometimes they will give room temperature directly. Right. So you need to remember the solution. No, but you need to remember the differential equation. This one automatically when you get solved, you will come across with the solution. So we get answer t equals, right? Yes, look here, t equals, we got it. Now let's go back to the question and we take all the details. When a cake is removed from an oven, its temperature is measured 300 degree Fahrenheit. When a cake is removed, so the data is coming to the statistics department. It is measured as 300. It means when t is equal to 0, capital T is equal to 300. Capital T for temperature. Okay, what happened? Yes. So now let me write what is given. So the given things are, okay, right? T is equal to 0, capital T is equal to 300. Forget it, I'm not putting a Fahrenheit or Celsius, no problem. Just write the value itself, okay? So it is not a must, you need to put the constant, the units, not necessary. 3 minutes later, look here, 3 minutes later, right? Yes, its temperature is 200. It means T equals 3 and capital T equals 200. Okay, so T equals 3. Okay, capital T equals 200. Okay, right? Yes, after that, how long will it take for the cake to cool off at 70.5? Okay, right. So it means how long they are asking the question. T is equal to question mark. T is 70.1 or 5. I don't know what values I gave. Anything you can choose, no problem, as you like. 70.5. So I gave 70.5. Maybe in the class I gave 70.1. No problem. Anything you can choose because we changed the question. And the room temperature is how much? 70 degree, right? So capital A is equal to 70. These are the details given. Okay, we'll go back to the equation, right? So this is my equation, right? So capital T is equal to A is 70 plus my C I don't know, e power minus kt. So the one constant has been gone already. So this is over. So at least we need what? 2 conditions. At least we need what? 2 conditions. Why? We have 2 constants. One is C, another one is K, right? Yes. So we have two conditions, you see, condition number 1, condition number 2. So first thing we are going to find C. What we are going to find? To find C, right. So to find C, what is the condition? T is equal to 0, capital T is equal to 300. Okay, right. So this is your equation, right? So T equals 70 plus C e power minus kt. So T equals 300, okay, and equals 70 plus C e power minus k, T is 0. Of course, this is 1. So 300 minus 70 is equal to C. So which is equal to 230 is equal to C. Am I right? Yes. So C is equal to 230. So what we need to do? We need to go back to the equation. We have to put it here, right? So T is equal to 70 plus C is what? 230 e power minus kt. So we got the solution. Not solution, we got the constants. Okay. First constant ready. Now second constants to find k, right? Yes. Again, take this equation. What is the condition given? The second condition, T is equal to 3, capital T is equal to 200. So T is equal to 3, capital T is equal to 200. Okay, right. So let's go back to this equation and put the value. Capital T is equal to 200 equals 70 plus 230 e power minus k times 3. It's a big equation. When you directly go to the calculator, sometimes it may take too much time to get the answer. So try to simplify as much as possible and then do. For example, 200 minus 70 gives what? 130 is equal to, let me write the step, otherwise you'll ask how 130 came. So 200 minus 70 is equal to 230 e power minus 3k. Teacher, can I do it directly? Okay, try. If you get the answer, it's well and good. Okay, no problem. So 130 equals 230 e power minus 3k. At least you put in this stage, it will be okay for you. So 130 alpha equals 230 alpha e power, okay, minus 3 alpha x. 130 230 e power minus. Shift calc equal. So what is my answer? See, it's taking more time. I told you all the decimals you have to write. So k equals, yes, I got it, 0.1901816,195. So this is my k value, right? Now go back to the equation. This is your equation, this one, right? 70 plus 230. So T equals 70 plus 230 e power minus kt, e power minus kt. So k, I will put it, T equals 70 plus 230 e power minus 0.1901816,195 times T. So we got the solution for the temperature. Okay. Now let's go back to the question. This is what we all find out. Constants ready, room temperature ready. Right, let's go to the question. What is the question? What is the time when the temperature reaches 70.5? So what we are going to do when the temperature reach, the question is, let me write the question, okay. When you will get the temperature, oh again I forgot, sorry, 70.5. So temperature is equal to 70.5. So 70.5. Okay, let me reduce. Okay, 70.5. Okay, right. So this is the one I'm taking here, right? So 70.5 is equal to 70 plus 230 e power minus 0.1901816,195. And then T is your X. So let me start this putting in the question. I think it is also a big number. So let me do one more step here. 70.5 minus 70. Okay. So it will be 0.5 equals 230 e power minus 0.1901816,195 T. Okay. Right. If you are getting the answer, go ahead. No need to simplify. Okay. Right. So 0.5 alpha equals 230, right? Alpha e power, okay, minus 0.19018169195 bracket open alpha x bracket close 0.19018169195 shift calc equal. So let me have the value of t is equal to what answer we got in the class. I'm not sure. And some people can think, why teacher, you can share the screen, calculator screen, you can do it in this tab itself. While recording, I cannot minimize the screen and I cannot bring the calculator back. I need to have. So this is 32.23879.629. So this is your time. Okay, right. Yes. So this finishes your solution. Now it's clear. Idea is same. So just go ahead with this, right? I'll do one more questions on Newton's law, which is another question also, which is because many students are finding statement questions as difficult. So let me do one or two questions more so that it'll be easy for you. Yes, let us read this question. Right. A cake is removed from the oven at 210 Fahrenheit. So cake is removed. So time t equal to 0, capital T is equal to 210. And left to room temperature, which is 70 degree, right? So the room temperature A is equal to 70, right? After 30 minutes, so it means T is equal to 30. The temperature of the cake is 140, right? When it will be 100, so it means T is question mark and the temperature is 100. Okay, clear? This is the data given. So I have to start. Yes, I told you how to start. What is the differential equation for Newton's law of cooling? dt divided by small t is equal to minus k into t minus a. I think this is what I use. Let me check because you should follow the same. For me, I know which one will come first, which one will be coming second. Minus k t minus a. Yes. Minus k t minus a. Right. Okay. So let us use variable separable method. Dt divided by t minus a is equal to minus k dt. Okay, t with dt, right? And a small t with dt and dt and dt. Oh, sorry, I pressed something. No, I have to close it. Sorry, s. dt and tt. Okay, it's in the numerator. Yes. So what I have to do? I have to integrate now. So integral. So ln t minus a is equal to minus k t plus integrating constant c. So ln is having the base e. So pick and tick rule, t minus a e power minus kt plus c. So I just pick this one, right? Together all. So which is equal to e power minus kt e power c, which is equal to e power minus kt c. I told you this is a constant. So t minus a is equal to c e power kt. So t equals, this a goes that side, a plus c e power minus kt. This is the solution of Newton's law of cooling differential equation. Okay, right. I think the letters are a little bit cross way. I don't know. My iPad is cross. Sorry, no, Samsung tab is cross. Let me try to write equal way. Okay, right. Now, what is the next one? We have how many constants here? 1, 2, 3 constants are there. So first thing is we need to put the room temperature. So put the room temperature. Okay, A, right. So what happens now? T equals A. How much is A given? A is 70 degree, right? So A is equal to 70. So 70, A is equal to 70. 70 plus c e power minus kt. So this is the first part. Now we need to find two constants. You need to find what? Two constants, right? Yes. So let us find the first constant. So to find now c. Okay, right. So what is the condition I'm going to use? I'm going to use the condition t is equal to 0, capital T is equal to 210. Okay, so t is equal to 0, capital T is equal to 210. Okay, t is equal to 0, capital T is equal to 210. Okay, right. So let's start. This is your differential equation. So let me write here t equals 70 plus c e power minus kt, c e power minus kt. So t equals 210 equals, let me put a line, 70 plus c e power minus k into 0, t equal to 0. So 210 is equal to 70 plus c e power k 0, which is 0, sorry, it is equal to 1, because e power 0 is 1 or e power minus 0 is 1. So this is c. So what we are going to do, 210 minus 70, which is equal to 140, which is equal to c. This comes as minus. So c is equal to 140. So what happened to the equation? T equals 70 plus, this is the equation, right? C 140 e power minus kt. Okay. Now with this I'm going to find, let me write here, t is equal to 70 plus 140 e power minus kt. Now I have to put the condition t is equal to t is equal to. So let me go back to the condition. T is equal to 30 140, 30 140. So which is 30 and 140. Right. So what happens now? So this is t is equal to 140, which is equal to 70, right, plus 140 e power, okay, k minus k times t is equal to 30, right? Again, it's a big equations. So 140 minus 70, let me bring this side. 140 minus 70 equals 140 e power minus 30k, right? So 140 minus 70, am I right? Capital T is 140 and t is 30 minutes. Okay, let me check again. Yes, capital T is 140, right? So 140 minus 70 is 70 equals 140 e power minus 30k. So just put it in the calculator now. 70 alpha equals 140, okay, shift e power, okay, minus 30 bracket open alpha x bracket close, right? So after that shift calc equal. Okay, right. So what happens now? What happens? How much you are getting? Still the calculator is working. Calculator still working. I told you, see this equation itself taking more time. 70 equals 140 itself taking more time. It will come, otherwise we need to simplify more. How? 70 divided by 140, we can do it and make it simple. Then after that we can put in the calculator. So we put, yes, I got it, which is equal to k equals 0.023104,906. Okay, this is your k value, right? So what happens now? I'm going back to this equation. I'm going to put the value of this k. So which is equal to capital T equals 70 plus 140 e power minus this k value. This k I'm going to put it 0.023104,906t. So this is your equation solution, right? So constants gone, constant gone, constant gone, everything we calculated. Now we'll go back to the question. So what is the question? The question is, I think the temperature they gave 100. Yes. What is when it will reach temperature 100 degree at time t? When means at time t. Okay, yeah, right. So t is the question mark. Temperature t is equal to 100. So we'll go back to this equation, right? So t is 100 equals 70 plus 140 e power minus 0.023104,906, and t is your x. Let me go to the question. I'm not sure. Let me simplify because it's again big number. So I'll bring here 100 minus 70, which is equal to 30, equals 140 e power minus 0.023104906 t. So let me take this value, okay, in the calculator, right? 30 alpha equals 140 alpha e power, right, minus 0.023104906 bracket open alpha x bracket close shift calc equal. So I have to get the value of t equals, yes, I got it quickly, 66.67, right? All the decimals, nothing wrong in that. 177269. Every time make sure L minus R, you should get 0. Keep in your mind in the calculator, you should get this one. Otherwise, your answer is wrong, right? I think one more question I gave it. It is from our current textbook also, right? Let us do this question also, right? So let us make this question also, right? So before going to this, it is very clear, it is Newton's law of cooling, right? So let's start the equation. What is the Newton's law of equation? Which is the differential equation. dt divided by tt is equal to minus k times t minus a. Let us solve this one, okay, right? Let us solve this one. dt divided by t minus a, already I did 2 times, so that's why I'm not explaining anything, and then integrating, so you will get ln t minus a is equal to minus kt plus c, okay? So now e is here, so t minus a equals e power minus kt plus c, which is equal to e power minus kt e power c, which is equal to e power minus kt c. So t minus a is equal to c e power minus kt. So t equals, a goes that side, so a plus c e power minus kt. So this is the solution. How many constants are there? There are 3 constants, a, c, k. Of course, a will be given in the question, which is called as room temperature. Okay, right. So let us read the question here, right? So let us read. A thermometer is removed from a room where the temperature is 21 degrees centigrade. So it means this is the first situation, thermometer is removed, right? And the temperature is 21. So T is equal to 0, capital T is equal to 21. And it's taken outside where the air temperature is the room temperature, okay? So capital A is this one, minus 12 degree. After 1/2 minute, it means half minute is means what? T is equal to half minute, 0.5, right? T is equal to 0.5, half minute, half means nose, right? 1/2 minute, the thermometer holds T is equal to 10 degree. What is the reading of thermometer at time T equal to 1 minute? So what is capital T at T is equal to 1? How long will it take for the thermometer? How long? Again, capital T small t is equal to question mark, for the thermometer to reach minus 10 degree. So capital T is equal to minus 10. So let me write all these conditions here. Okay. So let me write in the paper. After that, I will go to this one. Wait. So small t is equal to 0, right? Small t is equal to 0. Capital T is equal to 21. A is equal to minus 12 degree. Then after 1/2 minute, so T is equal to 0.5, a thermometer reads capital T is equal to 10 degree. Okay. What is the reading of the thermometer? So thermometer, they are asking question mark, T is equal to 1. Okay, this is the question. And then how long? Again, one more question. How long? T is the question mark for the thermometer to reach minus 10 degree. Okay. Because I keep moving the screen, maybe you will get confused. So I'll write all the conditions here. So what is given? T is equal to 0. Capital T is equal to 21. Right? And the room temperature is equal to minus 12 degree. Okay. And what is the question? There are 2 questions are there. The first question, T is equal to half minute. Temperature is equal to 10. And what is your T? Okay. T is equal to 1. What is your T is equal to 1? Okay. Let me go again. T is equal to 0.5. After half minute, thermometer is in. what is the reading of thermometer at t is equal to 1? So this is not the question. The question is t is equal to 1, capital T is equal to question mark. Okay. And the next is how long will it take for the thermometer? How long? So T is equal to question mark. Thermometer reach minus 10. So capital T is equal to minus 10. Okay, these are the situations. Right. So let us write the room temperature. Okay. So room temperature, let me write here. T is equal to, room temperature is what? A, minus 12. Minus 12 plus C e power minus KT. First we will write the room temperature. After that we'll go for the next setup. Right. So what is the next setup? First, to find C. To find what? C. Right. What is the condition? T is equal to 0. This one. T is equal to 21. Capital T is equal to 21. Right. Let me start here. Right. Okay. So this equation, T is equal to minus 12 plus C e power minus KT. So T is equal to 21, right, which is equal to minus 12 plus C e power minus K into 0. So 21 equals minus 12 plus C. Okay, right, because this value is equal to what? 1. Okay, right. Now this 21 plus 12 is equal to C. What is 21 plus 12? 21 plus 12, which is equal to 33. 33 is equal to what? C. So what happens to this equation? So this equation is T equals minus 12 plus your C is 33. This is your C. Okay, C is 33 and then e power minus KT. Okay, so let me write again here the equation solution. T equals minus 12 plus 33 e power minus KT. So we are going to put the next condition to find K. To find what? K. Right. So to find K, what is the next condition? The next condition is here. T is equal to 0.5, capital T is equal to 10. So T is equal to 0.5, capital T is equal to 10. So go back to this equation. Capital T is equal to 10. Okay. And minus 12 plus 33 e power minus K. Okay. And T is 0.5. So let me go to the calculator and put this one. 10 alpha equals minus 12, okay, plus alpha e power, okay, sorry, 33. Sorry, let me cancel. Minus 12 plus 33 alpha e power, okay, minus 0.5. Minus 0.5 bracket open alpha x bracket close. So let me read the equation again. 10 equals minus 12 plus 33 e power minus 0. Shift calc equal. If I give this one, my K is equal to, wait, let me wait for the value. Yes, I got it. 0.8109302.162. This is my K value. Right. And then go back to the equation again. T equals minus 12 plus 33 e power minus 0.8109302162t. So this is your solution, right? Now let's go back. We got the value of K, we got the value of C, everything. Now we'll go to the question, right? What is the question? First question. Let us go for the first question, right? What is that? At T is equal to 1, what is your temperature? Let me read the question again. Look here. What is the reading of the thermometer at T is equal to 1? Okay, what is the reading of the thermometer means what? What is the temperature in the thermometer? Okay, right. So what is the reading in the thermometer? So capital T is question mark when T is equal to 1. So take this equation again. So which is T is equal to minus 12 plus 33 e power minus 0.8109302162 and your T is written. Now we'll put it. So this is the question mark capital T minus 12 plus 33 e power minus 0.8109302162 and the T is 1. Okay. So what we need to do, the same question, type again. So capital T is alpha x alpha equal minus 12. This one you just type in the calculator x. So minus 12 plus 33 alpha e power minus 0.8109302162. Okay, that's 1. So no need to put 1. Shift calc equal. So how much your capital T? Yes, I got it. 2.66666667. How many 6? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. One more 6 is there. Okay. 7. Right. So this is your capital T. Okay. Right. What is the next question? The next question is, let us go back again. The question. How long will it take? So T is the question mark for the thermometer to reach minus 10. So T is question mark. T is question mark. And capital T is equal to minus 10. Okay, right. Let's take this equation. Okay, this equation I'll take it. T equals minus 12 plus 33 e power minus 0.8109302.162t. So here capital T is equal to minus 10 equals minus 12 plus 33 e power minus 0.8109302.162, and the T is how much? It's a question mark, right? So we are going to put T only. So in the calculator you are going to put X. So let us write minus 10 alpha equals minus 12, okay, plus 33 alpha e power minus 0.8109302162 bracket open alpha x bracket close shift calc equal. So your T is equal to, I think 10 plus 2 minus 10 plus 12, so it is maybe something like 3 point, yes, got it, 3 point something. Okay, right, 3.456968707. Now clear? So this is very clear, all of you. So first you need to find the Newton's law equation. After that you need to find the solution. Then you go back to the question and get it. So that's all for application, which is population growth and Newton's law of cooling. So this finishes your 3.1. Okay. Please like the video and subscribe it and just pass it to your friends. Just share it so many people will get benefit of this. Okay, right. Thank you for watching. Have a good day. Take care. Bye bye. Very soon I will upload the remaining videos. Okay, bye.